Hi there, Lilac and Oak class. I'm so thrilled that you've decided to have a go at planning and creating and completing a scientific fair test. In this learning video, I'm going to teach you how to do that step by step. And I'm also going to focus specifically on the types of scientific writing that you need to complete in order to design and complete and write up a scientific fair test. So let's get cracking. Okay. The scientific fair test that I've thought you might like to have a go at is all to do with floating and sinking. So we've got a question here. Does the variable affect how well an object floats? So in terms of variables, we're thinking of all the different things that might affect how well an object floats. For example, perhaps the size of the object might affect how well it floats. Perhaps the type of liquid that it's floating in. Perhaps the weight of the object. Perhaps the container that you're floating it in. Perhaps the temperature of the liquid. And there's numerous other things that you might like to include here as the variables which might affect how well the object floats. What we're going to do is we're going to think about how to control these variables in order to design a fair test. Now, when we're talking about a fair test, we're thinking about which one variable are we going to investigate? Which one variable is going to sit right here at the heart, center of our investigation? For example, you might like to investigate the type of liquid. So you would have the question, does the type of liquid affect how well an object floats? You might like to have, does the temperature of the liquid affect how well an object floats? You might like to have, does the size of the object affect how well it floats? Now, for my model, I think I'm going to select, does the weight of an object affect how well it floats? So this is the variable I'm going to put right there in the center of my investigation. This is the variable which I'm going to change. So what I'm going to do is I'll just quickly copy that, and then that can go up there into my title as well. So now I've got completed my title of my investigation, my question. Does the weight of the object affect how well an object floats? So as I said, it's the weight that I'm going to investigate. It's the weight is the variable I'm going to change. But here's another key part of making a fair scientific test. I'm changing one variable and investigating one variable. All my other variables need to remain the same. They need to remain constant. Therefore, the temperature of the liquid that I use must remain the same throughout my investigation. The type of liquid that I use, I suppose the amount of liquid as well that I use, must remain the same. Okay? The container which I float the object in must remain the same. And the size of the object must remain the same. And that's a tricky one. That's a tricky one to design when it comes to the practicalities. Because I just need to somehow design an investigation in which the size of the object remains constant, remains the same, but the weight of the object changes. Here's what I was thinking. I was thinking about designing an investigation in which the container was the same each time, in which the amount of water and the type of liquid was the same each time, in which the air temperature, so I could note on there, air temperature, 20 degrees, 20 degrees, 20 degrees, 20 degrees, if I was adding more detail, was the same. Temperature of the water was the same. The size of the object was the same each time, but I need to change the weight of the object. So I was thinking inside the bottle, I could change the weight by adding on stones. In this first investigation, test, I could put one stone in and then put the stone inside the bottle so the object's size remains the same, close the lid, put it into the water, see if it floats or sinks. Then I could repeat this time with two stones, close the lid of the bottle so the size of the object remains the same, put it in the water, see if it floats and sinks. Repeat with 3 stones, 4 stones, and actually, I wouldn't stop there, I just ran out of room and didn't want to draw lots and lots and lots. I could put some notes here that I would continue this process until the bottle was full, for example. That's how I would actualize, that's how I'd turn my design from this into what it would look like more in reality. That's what we would describe as the method. The method is how you turn your design into reality. You could do that through writing, you could do diagrams, you could do it for a mixture of the two. It's totally up to you. Once you've done that, it's time to think about what you're going to measure. Okay? I'm going to measure. I'm not going to need to take any formal measurements. I'm not going to need to use a ruler. I'm not going to need to use a measuring jug or any other kind of measuring tool. Actually, the only way I'm going to take measurements is through my own observations. All I need to measure is I need to observe the bottle and determine whether it's floating or sinking. And I'll record my examples in a table. I've deliberately chosen you one where actually the taking the measurements is actually quite simple and easy. So I want you to focus on some of the more technical aspects of scientific writing. For example, creating a prediction. Now, prediction is one of the formal types of scientific writing that as a year 5 or 6, you need to really master. So what I've done for you is I've created 2 documents to help. Document 1 is this one here. This one here shows what a prediction looks like in year 1 and 2, in year 3 and 4, and most importantly for you guys, what it looks like in year 5 and 6. Okay? So in year 5 and 6, a prediction should have scientific language to create a generalized statement. The generalized statement I've used is, I predict that the weight of an object will affect how well it floats. That's my prediction. I predict it will affect how much it floats. That's my generalized statement, and I've used some scientific vocabulary in there as well. Let's see what's next. It says, use their scientific knowledge to justify this prediction, to explain why you think it. So I've gone on to say, I think that if you put enough stones into the bottle, its weight will increase so that it becomes negatively buoyant. When this happens, the bottle will sink. I predict it will take approximately 5 stones for this to happen. That's my prediction. And I've used this criteria from the year 5-6 prediction to help me. Okay. My results were nice and simple. I said I would record my results in a table, and I did. It's a really simple table. Okay. And just to remind you that I've deliberately chose an investigation where collecting the results should be nice and simple, so you could focus on the more technical aspects of scientific writing. As you can see, for 1 stone, 2 stone, 3 stone, 4 stone, right up to 8 stones, I just said, yeah, each time the bottle floated. When I put 9 stones in, something unusual happened. It didn't float or sink. It seemed to just stay suspended underneath the water, but not all the way to the ground. I didn't know quite how to record that, so I just put it as a yes/no. I'm going to come back to that in my conclusion. 10 stones, it sunk all the way to the bottom and then carried on doing it. And I stopped there. I didn't bother continuing because I realised and I spotted the pattern that no matter how many stones I was going to put in, it wasn't going to float. Those are my results. Next step is the conclusion. Now, for the conclusion, this document again is really, really useful because it shows all the things that you would need to include in a year 6 conclusion. Okay. But I've also helped you even further this one because I think a conclusion is a really hard thing to produce. I've written my own version of a year 5 or 6 conclusion. Okay. And I've used that criteria that I've just shown you to indicate and show exactly what a really successful year 5 or 6 conclusion looks like. This is included in the pack of resources that's been sent out this week. My recommendation would be to read carefully through Mr. McKinnon's version of the conclusion, look carefully through this success criteria of what a year 5-6 conclusion should look like, and then have a crack at doing it yourself. Okay? The same applies for your evaluation. When you're thinking about your evaluation, you're asking yourself, how accurate was it? So how accurate were your measurements, were your readings, were your results? You're thinking about your reliability. By reliability, I'm talking a lot about how fair it was. Did you only change one variable? Or were there other little sneaky variables which you didn't manage to control and which changed and might affect the reliability of your results? Now, the final thing I want you thinking is real world application. Now you've made this fantastic scientific discovery, what does that mean for the real world? Who would use that information? How would they use it? What advice would you use for those people? Again, a detailed success criteria of how to write a good year 5-6 conclusion we found in this document here, which is included in your pack. Furthermore, my example of a year 5-6 evaluation has been included here. My advice would be look through both of these in documents before you have a go at creating your own evaluation. Now you've watched the learning video, it's over to you. You could, if you wanted to, complete the exact same investigation as me. Okay? Or if you prefer, if you want to do something a bit different, probably a bit more of a challenge now, why not think about putting a different variable in the center? Why not investigate the type of liquid you use, for example? Why not investigate the temperature of the liquid? Oh, that could be an interesting one. Okay. Why don't you investigate the size of the object? Again, that'll be tricky because you're going to have to try and change the size of the object but keep its weight the same. Very challenging. Okay, that's why actually I've chosen this one for you year 5s and 6s. I think it should challenge you. My top tip is before you even attempt this scientific investigation, you're going to need to really brush up your understanding of floating and sinking. I put a couple of links and resources onto the school website that would help. My top tip would be before you try this investigation about floating and sinking, go back, revisit some of the learning you've done on floating and sinking, just to make sure that when it comes to it, in your prediction, in your conclusion, for example, you're really able to use and apply really good, precise, accurate scientific understanding. Good luck, guys. I can't wait to hear how you got on.